In the first part, we use annotations to generate a GenModel. Before we start, we have to configure Mitra in the project settings. We set the module path, which is quite similar to the Java class path. Now we import the original Ecore model and we create a diagram because the drop formation tool is based on a graphical syntax, and for that we need a diagram. This is the diagram automatically generated and layouted by the Ecore tools. Now we can open this diagram, the very same diagram, with the drop formation editor. The drop formation editor is a combination of GEF3D and the Mitra transformation language. Here we see the GEF3D version of the diagram. Actually, it's the very same diagram, also rendered by the Ecore tools, ported to 3D. We call that 3D-fied. The diagram is still editable, just as in the 2D version. Yes, and now we want to transform the Ecore model to a GenModel. For that purpose, we use a transformation, a Mitra transformation, and here we select a rule. And now we use the quick formation tool to transform the model into a GenModel. This is done simply by clicking the element which serves as the input parameter, and then the transformation generates the GenModel. Here we see the GenModel and we can examine its properties. Here, for example, the base package org.tctc10. This was specified in an annotation. You have another annotation here, or another property, create child, of the transition. This is set to true by default, and we want to change that to false by adding a new annotation. We delete the old GenModel first. We simply select the transition here and use the properties view to add a new annotation. Actually, this is not the functionality of the drop formation editor. This is standard functionality of the Ecore tools, which is preserved in the 3D version. Here we set the new annotation, we add a key. We have to know the key, of course, and then we set the value. It's a string value, false. This is later casted to Boolean by the transformation. Now we have set the new annotation, and as before we use the quick formation tool to create a new GenModel. Here it is. You see this is pretty simple. It's more or less like selecting another tool. And here we have the transition. There it is. And you can see the create child feature is set to false. We can use these annotations, but we can only use annotations if the original Mitra model, in this case Ecore, supports annotations. Ecore supports annotations, but for example UML doesn't. So it may be a good idea to use a different mechanism for adding these informations needed during the transformation. So we use a marker model here. And in order to use a marker model, we have to generate a marker model first. This is also done by a transformation, but before we do that, we create a trace model. The trace model is required by Mitra in order to resolve the source and destination relations. And traces are natively supported by Mitra, and also explicit trace models are supported by Mitra. So we have created the trace model, and now we can create a new marker model. The marker model is attached to the original Ecore model, and we have used a quick formation to create the marker model as well. the mechanism is just as in the previous steps. Now, in order to create a new marker, we want to simply click on the model element which is to be annotated with a marker, but we have to specify the marker model somehow. And we cannot select that marker model in the diagram because it's not visible. So we define a so-called auto-resolve parameter, and later during the transformation, if a rule requires a new parameter which is not selected in the diagram, it queries the auto-resolve parameters map and can then set the parameter automatically. So we have used the quick formation tool again. We have manually selected the model element, this is here the diagram, and the markers model was automatically resolved, and then the marker was created by the transformation rule. We can now set the properties of the marker. They were filled by the transformation using reflection and simply querying all the properties of the GenModel which is to be created later. Here we set the copyright text, just for demonstration. And we can create more markers. We can create markers for every model element. The rule simply requires an Ecore object, and since all elements are Ecore objects, we can annotate all the objects with markers. Actually, we can even annotate other Ecore models with markers now, for example UML models and so on. Now we create the GenModel, again using a quick formation. And we can examine the result to prove that the information added to the marker was actually transformed into the GenModel. Here we have it. Now, all these examples are not really the best use cases for drop formations, and the question here is why use 3D? And to demonstrate this, we add a new model. In this example here, we create a new class diagram, a UML class diagram. And this is only to demonstrate you why we use 3D in the first place. And this is the typical use case for the drop formation tool. Yes, we have a class diagram. It's empty right now. The editor here is the UML2 tools editor from Eclipse. And just as we did it before with the Ecore diagram, we open the UML class diagram with the drop formation editor simply by drag and drop the diagram into the drop formation view. Actually, the UML diagram is also fully editable. We do not demonstrate that here, but we use a so-called drop formation, and this is why we use 3D and the Mitra tool, because now you can transform selected elements from one model to another model. So we select a model element here in Ecore class and transform it into UML class. You'll see the traces are also visualized in this case. And this is a very convenient way to transform single elements. This is very practicable if you do not have all information to create a fully automatically transformation, so if you do not want to transform everything. And you see some green markers here, some green traces. These were created by automatically triggered rules. You can read that in the paper. Yeah, and this is why we need 3D here. Actually, the Ecore2GenModel case study is not a typical application or case for the drop formation tool, but as you have seen, it can be solved with the drop formation tool as well.